Welcome to Allplan Engineering Quickstart Lesson 12. In this lesson, you will learn how to reinforce walls using PythonParts and welded meshes. Let's activate the 2+1 animation window view to see the model better. Walls are the main vertical structural elements for this cafe. They are surface elements that often have openings for doors and windows. As you can see from the FEM analysis, additional reinforcement needs to be added around the openings due to the presence of stress concentrators. As you can see in the FEM diagram, the typical reinforcement for wall is small, so it can be easily covered with welded meshes to reduce the required labor on site. You will deactivate not the partition non-concrete walls by loading Lesson 12 Engineering Favorite. Next, you will access the project-specific basis by double-clicking on the background. Load here the Lesson 12 Favorite as well to automatically activate the proper drawing selection. On the right side, go to Engineering, Reinforcement Drawings, Cafe, and Checker Drawing. You will rename this drawing into Wall Detailing. Now close the window. Make sure the scale is set to 1:50, as this is the scale we intend to detail the wall elevations. Now click on Create Section tool. Select from right to left the top wall. Click above it to indicate the view direction, and then by doing 2 diagonal opposite clicks, you define the beginning and depth of the section, end the function by hitting Escape. Position the result under the 3D model and center its title. Go to the left and pin the Properties panel by clicking on the hobnail. Now go to Library tab and choose Default, PythonParts, Engineering, and select Wall Corner Type 1. There are many parameters that help you adapt this reinforcement detail. To follow this example, simply load a favorite so that you inherit all parameters. Zoom in on the plan view of the 3D model and move the cursor next to a wall. Click to position the reinforcement detail. Many handles and dialog boxes appear in which you can arrange further this detail. Let's change the anchorage length from 50 centimeters to 80 centimeters on both sides. In different views, you have different handles. Go in the elevation section and extend the reinforcement cage so it matches the full wall height. That's it, the 3D reinforcement cage is properly positioned. Close to generate it. Now choose the enclosed edge reinforcement by double-clicking on it. As before, you should load a favorite to match instantly the chosen parameters. Simply move the cursor next to an opening and the reinforcement shape will be previewed. You can change at any time parameters like the stirrup shape, spacing, length, or settings for the longitudinal bars. Click Close to generate the reinforcement. The created reinforcement can be multiplied like any object by using the Copy tool. When making a selection, it's recommended that you use a filter. Select Filter by reinforcing bar element, steel grade, and check B500B. Select now the edge reinforcement, pick a transport point, and multiply it to the other openings. Double left-click on the section and click Def to change the view properties. The Display Hidden Edges will be activated in order to better see the edge of the wall. Select Span Reinforcement, input the concrete cover of 25 mm with a negative value, then click on the lower left corner and the top right corner of the wall, and then hit Escape. To insert openings, select Enter Openings, input a positive concrete cover, define the opening by clicking on two diagonal opposite points, and hit Escape. Alternatively, you can use the area detection feature to automatically detect polygons. With this feature, you can simply click inside a polygon and the opening will be offset with the concrete cover. This function is useful especially when dealing with complex openings. Click OK to get to the next step. You can choose a mesh from the database or create your own. Other parameters are regarding the distribution, transversal or longitudinal, the orientation and the overlapping. Click OK to generate the meshes. You can now use the Dimension Overlap tool to measure the overlapping distance of the meshes. To dimension the stirrup spacing, you right-click on one of them and select Dimension Line Label. Deactivate the bar markers and remove the length, then position the line and the text. The description of the meshes can be easily moved to improve the aesthetics of your drawing. You can also describe the longitudinal bars used around the openings with a fan-style label. In some situations, an isometric section can be really helpful to explain the reinforcement detail. To do that, use the Section tool with the free option activated, then select an isometric view in the lower left corner. Select from right to left the desired corner. Then on the 3D model, mark the area of the section by doing two diagonal clicks and hitting Escape. Once positioned, you can limit the detail by doing two diagonal clicks and ending with Escape. To remove the meshes from this section, right-click on it and select Remove from View. Then apply a filter by Mesh. By Mark, select the marks, and finally select the entire section. Some colors might be difficult to see on white, so you can deactivate the colors in Plan View to see the reinforcement in black and white. To dimension the bars in this isometric section, simply right-click on any bar and select Dimension Line Text. The dimension line type is the most suitable for stirrup placement, while the fan dimension line is suitable for the longitudinal bars. You can also activate shadows to improve the detail's visibility. "3D reinforcement" means automatic quantities. To generate the bending schedule, simply go to Reinforcement Reports and select Reinforcement Bar Legend, choose the first template and click OK. In a similar manner, go to Mesh Reports and select Mesh Legend. Select template number 10 and click OK. Even more interesting for the fabricator is a mesh cutting diagram. This will illustrate how the required meshes are obtained and also check the remainder meshes. Go now to the Layout Editor. Double-click on the background and choose Drawing 101. You can load a page favorite to add the title block and the border. Then click in Layout Element, Building Structure, Derived from Building Structure, and click on Select Drawing Files currently loaded. Then click on the white page to position the result. To export to DWG format, simply select Export to AutoCAD Data. Pick the wanted drawings and click OK. A DWG file with model space and layout space is generated. All information is editable and stored on layers. In our next lesson, you will learn how to reinforce complex concrete shapes with innovative functions.